Hello and welcome to the Video Assistant Resource, or VAR, for your description of your global pattern of earthquakes. Now, just before we get into that, let's just remind ourselves of a few things that we should know by now about describing distributions. You got this from the last one, which we did for volcanoes. So, distributions, remember, where something is and where something isn't, so it's how it's spread out across an area. Then you've got your types, you've got regular, concentrated, linear, circular, and the all-important compass directions. Don't forget those. And then we're going to relate them to the factors underneath. So you can refer back to this slide at any stage if you need a reminder on how to describe your distributions. Right, next up, you will go in, open your map. We'll take a look at it in a moment, but let's have a wee look at the first question. As usual, these are bookmarked here. So you're going to the global overview and using slide 2 as a guide, describe in detail the global distribution of earthquakes. You need to make sure that you're referring to places. Right, here we go. Here's the global distribution of earthquakes. Now, a quick reminder of how to use this. If any time you can turn on or off the layers if you need them, and if you need the key or legend, it's just over here and you can get those at any stage. So where they are and where they're not, you should be able to spot a pattern. You perhaps are looking for things like a linear pattern. You're looking for some clusters of them, and in particular when you're looking at how they're related to underlying factors, well, if I turn that layer off and on, that should be a big clue to you. So hopefully that's a relatively simple question to get you started. Okay, let's move on to the second one. We're going to zoom in here to bookmark number 2, and we're going to take a look at the continent of South America. Just zoom in a little bit closer here, and of course you can move around. You're in charge of this, moving around the map if you need to. But we're taking a look at South America, and again, the question is describe in detail the distribution of earthquakes across the continent, and particular attention to the relationship between the plate margin and the location of the earthquakes. Now again, this should be a lovely little straightforward question for you. I think there's a pretty clear pattern there. There's definitely a word beginning with L that would definitely describe that, and indeed, let's turn this off and on again. Big clue. Where they are, where they're not, and the underlying factor they're related to. Don't forget to name your places and to refer also to the compass points. Now, just a quick point here, if you want to name the places, if you go in here to your topographic map, select that as your base map, you can zoom in and you'll be able to get the names of some of the countries there. And if you can't read them, oh well, you can just turn that layer off and that will give you a little bit of an idea of the names of the places. Dead easy, just got to change the base map. Okay, let's move on to the next one. Now, we're going to go up this time to North America. Go to bookmark 3, North America. See, here we go, the bookmarks, number 3, North America. And we're going to start off with this question here. To what extent are earthquakes here concentrated along the west coast? If you know anything about North America, you'll know California is along the west coast, and California is undoubtedly earthquake territory in the United States of America. But my question is this: to what extent are the earthquakes concentrated here? So again, think of your terminology. Think of things like these: linear, circular, concentrated, spread out, that kind of thing. Okay, so you need to take a look at that. To what extent? Now, a wee tip on the to what extent questions. You'll see that there are different boxes here that are going to help you. To what extent are the earthquakes here concentrated along the west coast? Now, a to what extent question implies that the answer is not a simple yes or no or one or other. There are two sides to it. On the one hand, however, and you should always finish off with a conclusion. What is your overall view? To what extent? To a limited extent, to a certain extent, to a large extent? Those are probably your 3 choices. You choose the one that you think is right. To a limited extent, certain extent, large extent, based on what you find. Okay, then we're going to narrow the focus down a little bit more in North America, and for this you're going to need to set up a filter. Now there's the instructions step by step, but let's jump on in and I'm going to show you what we're going to do. Right, so it's the global earthquakes layer, this one here, and this is your little filter icon. If I hover over it, you can see that the filter's there. You click on it and you've got three boxes that you need to do something with. So we just simply click the down arrow here to get your drop down menu. You're going to scroll down until you get mag for magnitude. Now we're going to try and select here the bigger magnitude earthquakes. So earthquake is, or the magnitude is greater than, and let's choose magnitude 5. So you just simply type that in and you apply filter, and what you see what happens? It takes all the earthquakes away and it only puts in now the magnitude 5 earthquakes. Now isn't that a very, very different pattern? So now you've done all of that. There's your steps there. You're over here. Compare the maps. So the one that you've just described and this one you've just set up. Describe the distribution of the larger earthquakes across North America compared to all earthquakes. So we're kind of coming back again to the whole notion that earthquakes in North America and United States of America tend to be concentrated along the west coast. Now, is that really true? Well, this map with the larger earthquakes certainly tells quite a different tale. And you can write your answer in there. Okay, and then we're going to finish off by taking a look at one day in earthquake history. So we're going to change the base map to topographic and we're going to go to overview again. So let's go base map, topographic, and let's go to the overview for this. Okay. Now what we then need to do is to select this layer, global earthquakes, on that one day, and we'll turn off the other layer of the global earthquakes that have been working up. This is just one day. Now we're going to pop this on to get the legend, and we can see that the circles, the size of the circle is proportional to the magnitude of the earthquake. Bigger circles are bigger earthquakes, but it's also color coded. The red colors are your bigger earthquakes as well, so you can see that. Okay, that is your first map. So you need to start, I'm going to change this now, start by describing the global distribution of earthquakes. Refer to the relationship between the earthquakes and the plate margins. There's your plate margins, there's your earthquakes. You also need then the different sizes and how they're distributed around the world. Now remember, this is just one day, so you're not going to get all those linear patterns you got from the other ones, because this is just one day's worth of earthquakes. You might be actually quite surprised how many there are, but it's only one day. But where are the bigger earthquakes that day? So take a look at South America. Big earthquakes there. North America. Oh, and what around about here in Southeast Asia? Again, you can go in and you can have a look at the names of the countries there if you need to get any of them. You're in charge of moving around the map. So that's starting off with the overall size and the overall distribution across the world, including reference to places. But we're going to take a look here at a particular location where there was an earthquake on this day in history. So we're going to go into bookmark 5, then bookmark 6. So bookmark 5 is just going to give you a little bit of an overview of Alaska. That's where we're going. So the North American, there's Alaska. And you can see that there's a rather large earthquake here. But we want to zoom in really close, so let's come in close to that earthquake. Now again, you can move around, you're in charge of it, and we're going to zoom in really, really close to this cluster of little earthquakes that have occurred on that day. Now what you're going to then do is to zoom into those circles that we've just done, and you're going to open up the pop-up box. Now that's going to give you some information about each of these earthquakes, and you're going to find the 4 biggest earthquakes in the location. And you're going to record their magnitude or their size and their depth. So the pop-up box, the 4 biggest. Now I'm going to pick one that's definitely not one of the 4 biggest, and it's going to be this one. Right, so you click on there, and there you can see it's a depth of 16 kilometers and a magnitude of 4.6. So again, one that's definitely not the biggest. Magnitude of only 2.9. So what you need to do is to go around and find the 4 biggest. Now remember, the bigger the size of the circle, the bigger the earthquake, So that's going to give you a clue as to which ones to select, and when you find the 4 biggest, you're getting the size and the magnitude there, and you're getting the depth. You're going to add that into your table. Okay. Now, just one thing to point out here. I want to get this. Let me see which one's the best one to choose for this. So yeah, if we pick this one here, we can see that the depth of this earthquake is over 30 kilometers. Keep that figure in your mind, over 30 kilometers. Okay, next we're going to do a little bit of a comparison of that day with California. So you go to the bookmark on the close-up for California, and you can just about see these little earthquakes appearing. Again, if you're struggling at any stage to see anything, well, why don't you change the base map? That'll allow you to see them a little bit better. They'll just pop out, or perhaps even the light grey canvas one will make them pop out just a little bit more so you can spot them. Now, there are about 6 or so earthquakes in California that day. So what you need to do here is just to choose any 4 of them. It doesn't matter, any 4 of them at all. Click on there and you're getting the same information. You're getting the magnitude and you're getting the depth. Now, can you notice that depth? What was the number that I told you to remember for Alaska in terms of depth? Do you remember it? Did you say 30 kilometers? You did. Good for you. Oh, that's quite different, isn't it? So you just choose any 4 of those, fill that in, and you'll have the sizes and depth in Alaska, sizes and depth in California. And then here's your question. Which location, Alaska or California, where the earthquake focuses? Remember that the definition of focus, do you remember? It's the point under the ground where the earthquake actually happens. What's the epicenter? The epicenter is the point on top of the ground directly above the focus. So in which one is the focus deeper? Okay. Then you're going to have a wee look at what it was actually like to experience this earthquake. So you can see here that there was a tsunami warning triggered because this is happening. Let's go back up to here, Alaska close-up. This is happening under the ocean. Let's turn on the imagery layer again. Do you see that? This is an underwater tsunami, potentially tsunami-producing earthquake. It's right beside, you see here, the trench, right on the trench, where you have the subduction taking place. And those are the places that are most likely to produce your tsunamis. So if you want to click on that video, you can see what it was like. This poor woman and her 3 kids and all of her dogs. This is what it was like to experience this. Now, this was a big earthquake, the biggest one. I'm not going to tell you what it was in terms of size because you've got to find it, but it was a big earthquake. So what was it like experiencing it? And that brings us to our very final question here. Now, I'd like to finish these 3 tasks with an opportunity for you to really shine. This is the final challenging question. Again, I'm not giving you the figure just yet, but why did such a large earthquake, you'll find that by clicking on the pop-up boxes, of course. Why did such a large earthquake cause such little damage, no deaths or injuries? Now, it's saying here, what's this, for some clues. So I'll give you some clues in this one. Now, the first one here, earthquake caused no severe damage due to its location relative to the sparsely populated Alaska Peninsula. I know, it's sparsely populated. What does that mean? Well, a sparsely populated area is an area that doesn't have a lot of people living in it. So let's zoom out a little bit and get the whole context for Alaska again. And I've got a layer here that you can turn on showing the Alaskan towns. Now if we look at the key again, I've set this up so that, again, the bigger the circle, the bigger the settlement, and it's color coded. So small yellow circles are towns that have very, very few people living in them. Now this settlement here, let's click on it. The state capital of Alaska has got Anchorage in it. Over 250,000 people live there. But you can see actually that this is the only major settlement in Alaska. In fact, if we go in even closer still, you can see that the little settlements nearby are very, very small. Now, You can even click on here and it'll tell you how many people live in this settlement. Let's find out, shall we? Absolutely none whatsoever. Population is 0. Nobody lives there. What about there? Nobody again. And this one? Oh, 870 people. Right, well, you can zoom in and see what the conditions are like for those 870 people that live there. Go and have a wee look in. Oh, look, we have found our first settlement. It's tiny, isn't it? And whenever it says sparsely populated, this is the kind of thing that it means. So you can go and have a little bit of an explore. Why don't you? Have a virtual tour of some of these locations in this part of the Alaskan Peninsula, and you will discover that there is hardly anybody that lives here. Now that's part of the reason. Very, very few people living nearby. Go and have a wee look at some of those settlements and imagine what it would be like living there. Very, very sparsely populated indeed. So that's one of your first clues. It's sparsely populated, right? One of your other clues, well, you can have a wee look at the distance. You can use your measure tool. How far away is that? It's like, nearly 200 kilometers away. The biggest settlement, now the biggest one that I could find, you can start to look at the colours for this one. There's one poked in there, right? Click on that one. Oh, 6,500 people live there in Kodiak. How far away is that? Well, again, I'm not going to do it for you, but you can get your measure tool and you can measure it out and see. That's your first major settlement and how far away it is. So, sparsely populated, distance, and the other thing, the other big clue that I want to give you, and it comes back to this little table you filled in. How deep was it? You can have a look at that as well. So those are your 3 clues, 3 things to think about for in here, how sparsely populated it was. Again, get some information from the map. Go and find stuff out and impress me with the stuff you put down there. How far away it was from any bigger settlements. And thirdly, how deep it was, and why don't you throw a wee comparison in there to California in the same day? There's your opportunity really to show me some really cool stuff and really good thinking. Okay, so that's everything I think I need to say to you. So it only remains for me just to wish you great fun in doing it. I love using these GIS maps and I really hope you have a good time exploring it as well.